And on the introduction, I had said the integration by parts normally is used to integrate products or functions that you multiply together. Basically, there are 5 types of functions, and given by the acronym LIATE. So you just have to remember LIATE, where L stands for log, I is inverse trigonometric. Normally, we shall not be able to use it so much, that one. Then we have A, which is algebraic. Algebraic are the x squared, x to the power 3, x, basically the polynomials. Then you have trigonometric functions, basically the sine, the cos, the sine hyperbolic, the tan, the cos hyperbolic, those functions. And we have basically the exponential function, which you normally do. So, how do you integrate products of functions? There's a formula I've given you there. U dv is equals to uv minus v du. So if you want to integrate by parts, you have to recall that formula. That formula is very important. You have to recall that formula. U dv is equals to uv minus v du. So as you recall on product rule of differentiation, you are calling one function u and we are calling the other function what, v. Now integration by parts, we shall call one function u and one function dv. We shall have v, we shall have u. So we shall have one function, we shall call it u, and one we shall be able to call it dv. Now, which function do you call u and which one do you call dv? So again, it is given by that acronym, LIATE. LIATE. So you can be able to see if our function is if you have two functions, a log and an inverse, the log will be given as u, and then the inverse will take the other one, which is the dv. If I have a log and an algebraic function, again the log will take the u, and then algebraic definitely will take the dv. If I have an algebraic function and an exponential function, from the arrow going downwards, you can be able to see that the u will be the algebraic and the dv will be what? Exponential. So if you call one function u, the other function definitely will become what? Will become your dv. Will become your dv. So you call one function u, the other one given, so you shall be using LIATE basically. We shall be using LIATE to be able at least to be able to come up with those. So what I want you to know are functions we call u, we normally differentiate. Normally differentiate those functions that we call u, and the functions that we call dv, we normally integrate. So any function that we shall be calling u, remember when you integrate when you integrate the dv, we need the value of v. According to the formula, we say that what u dv is equals to uv minus v du. So we need a v, and how can you? Where shall we be able to get the v? We shall get the v basically by what? Integration. And then we need a du. So the du, we shall get it from where? From the differentiation. So that's why we integrate, the other function we do what? One function we integrate, the other function we differentiate. I think I can be able to do an example to demonstrate this. So let me do an example. So the formula is very important to remember, and then the acronym LIATE to be able to see which one you shall be able to supersede. So you can be able to do an example here. And you see how it works. So example, let's integrate x let's say exponential x dx. Very easy function. So you can be able to see this one is a product. So this one is a product of two functions, x and exponential x. So we shall use integration by parts. It's called integration by parts. So which function shall we call u? Which function shall we call what? Shall we call what? Our dv. So I'll come here to the acronym LIATE, first of all. LIATE. So basically, the x will be on the side of the algebraic. Then the exponential x will be on the side of the what? Of the exponential. So we had said what? According to the arrows that I've given, is that when you go like this, like that, the first one that will appear will become your u, and automatically the other one will become your what? Your dv. So you can be able to see LIATE. So x is basically the algebraic, the polynomial. I think I had said that. Then the exponential function, just the exponential function. So if I do my arrow like that, going horizontally or going down, the x will become my u, according to the arrow. If I'm moving from what? From right to left, again the dv will start. If I do like this, these are the direction like that. Again, the dv will be given by exponential x, so you don't have any problem in that. So what I'll do, I'll call u to be x, and then I'll call my dv to be exponential x. Now we had said what? According to the formula, we need v and we need what? We need v and we need what? We need what? V and du. So basically what I'll do here, look at what I have here on the integration. So this one, I'll call it u. Let me use another pen for you to be able to see. So the whole of this one here, I'll call it what? I'll call it u. It is there. Now, the whole of what is remaining here, I'll call it what? dv. So here I'll need to add a what? I'll need to add a dx, whatever that remains. Because when you're integrating, you must have at least a dx. So whatever that is remaining there, I'll be able to call it dx. So when we call one function u, the dv will have a function of dx. Will have a function of dx. Now we said what? Now I'll be able to come and differentiate this one. So when you differentiate u, you'll get du. Or I say du dx. That one a good way of doing it. Yeah, okay, du dx is equals to 1, it's still okay. And then here I integrate. When I integrate dv, and then I come and integrate this other side exponential x dx because I want a v. When you integrate dv, you get v. When you integrate exponential x, you still get exponential x. The integration of exponential x is still exponential x. So from here, I can be able to come and make du the subject of the formula here. Basically, du will be given by what? By dx. D will be given by dx. So I need, now I have the two things that I need. So I'll just plug them in the formula. So I have this one, which is du is equals to dx, and I have this one, v is equals to exponential x. So I just need to plug those ones in the formula. So let me plug those ones in the formula and see what I'll get. So you said the formula, you must remember it. So we had said the integration of u, the integration of u dv the integration of u dv was given by uv minus v du. So I have everything that I need. So this one will be given by what? Our u was, I go back here up, go here up. My u was given by, I'd call it x. So my u was x, so it is there. My u is x. I have my v here, and I have here my du. So that those are the things that you need. So let me go down and see what I have. So my u had given it as x, that's the first one. And then my v, I've integrated my v. Check my v here is exponential x. minus the integration of my v is still exponential x, and then my du is what? Dx. My du is dx. So I've replaced everything that is there. Now, this first part here, you can be able to see this one has already been integrated. So there's no need to integrate. So this part has already been integrated. The first part always has been integrated. So you don't need to integrate. So far, this one has already been integrated. So you don't need to do anything to it. Just need to multiply or be integrated. So you're able to see there's no integration sign. This one here, there's no integration sign. So I'll not concentrate on there. I'll concentrate on this other side, this part that is now being integrated because it has an integration sign. So the final answer that I'll have is x, exponential x. When I integrate an exponential x function, I'll still get exponential x. And here now I can be able to add a constant of integration now. I can be able to add a constant of integration. So this part here, the one that I'm circling in what? All the time, this part here, the first part here, mostly it will be integrated. So you don't have to integrate it again. The only thing that we integrate is the function here that does not have a what? That has an integration sign. That has an integration sign. And when you integrate exponential x, you'll get exponential x, and then you add a constant of integration. So we are done with that example. So what are we integrating? We're integrating exponential x dx. That's what you are doing. That is what you are doing, integrating that, and we have gotten the answer. By doing what? By calling one u and calling the other one v. Let me do another example to just demonstrate now. Do another one just to demonstrate. Number 2, the integration of, let's say, x sine 2x dx. So last time we had done an integration by substitution. Integration by substitution. So you guys you have to be good at that. So again, I'll come to the acronym LIATE. So going down is always the u, and going up is always the dv. So you just have to know one. You don't have to know the two. If you know one, the other one becomes basically the opposite. So we have our x will be there. That is the algebraic. Then we have the what? We have our sin x, that is the trigonometrics, sin 2x. If you go the arrow coming from down dv, you can be able to see that sin 2x will become my dv. If you start with the arrow that is going down of the u, again you can be able to see that your algebraic will be what? Will still be what? U. So it doesn't matter where you start, either going up or down, you still get the same thing. So basically the arrow is showing you that the first function you meet will become your dv from down going up. From up, the first function you meet will become your what? Your u. So again here u will be x, and then here what? dv will be now whatever that is remaining, sine 2x, and remember there must be a dx. If you go back to what we have here, check now. Check what we have here. This one, I've called it my u. It is there. Now whatever that is, the whole of this one that is remaining, this one, I've called it now my what? Whatever that is remaining, the whole of that function that is remaining. Whatever the function that is remaining, the whole of the function that is remaining here. This one here. The whole of this one here. I'm calling it my what? My dv. So we had said in the previous example, we take even the what? So the whole of that one, I'm calling it my dv, whatever that is remaining, my dv, together with the dx. Very important, because when you're integrating, we must be able to know you're integrating in terms of what. So this one, remember when you integrate you'll always get the u. So I want to jump some steps. When you integrate x, you'll always get the dx. Even if you do the other way, du dx, you still get the same thing. So remember, when you integrate x, you'll get dx. When you differentiate x, you get the x. When you differentiate u, you get the du. Is a faster way. Instead of doing du dx and making the subject of the formula, there's no need. You just remember, when you integrate u, you get du. When you integrate x, you'll get dx. What about x squared? We shall come to that. So this one, now to get v, I must integrate this function, sine 2x dx. I must be able to integrate that function to get v. Remember, when you integrate dv, you will get v. It is the opposite. So I want to integrate sine 2x. So before the cut, we had said the integration of when you have a function multiplied by 2, what we normally do, when you integrate sine, we normally get a minus cos. So we'll get minus cos 2x. That is when you integrate sine. Check from the table. When you integrate, you'll get cos 2x. But we said in integration, using chain rule, I'll come and differentiate inside. Whatever that is inside, I always divide. I always divide with that. Whatever that is inside, in differentiation, we are multiplying. But in integration, what we normally do is divide. We always divide using what? Integration. Any function that you are doing, remember, even the power rule, add 1 to the power and divide. So we normally divide. Now here, please don't add a constant of integration. No need of adding a constant integration. The constant of integration will come later. So I have what I need now. So I'll go back to the formula. So the integration of u dv, the same as uv minus v du. So I'll just put the things that are there. So our u was what? Our u was x. Our v was sine 2x. No, our v, it is here. Sorry for that. Our v I've integrated. I just input it. My v is what we have integrated here. My v is given by this negative here. Negative. V is given by negative cos 2x all over 2. And then now minus, my v is still what? Negative cos 2x all over 2. And then my du is still dx. It is here. My du is dx. Remember, I differentiated u to get du, and I've differentiated x to get dx. So this is here, the one that I'm needing. My du is still what? Dx. So I've replaced everything. I had said the first bit we just simplify or multiply. It has already been integrated. So let me simplify this one. This one will be given by, I can able to remove the 2 outside. So I can have, let's say, negative x over 2. Let's say, for example, cos 2x. Then I have a negative times a negative, that is positive. I can able to remove the half outside, is not playing any part in the integration. Cos 2x dx. Cos 2x dx. Negative times a negative is positive. Now, this, I'd say the first part I've already integrated. So my work is now to integrate the second part. The second part is the one that has a lot of work. The second part is the one that has a lot of work. So I need to integrate the second part. So this one will be given by negative x over 2 cos 2x plus a half. Now, when you integrate cos, from the table that I gave you, when you integrate cos, basically the opposite of differentiation. So I should be able to get sine 2x. But again, I come inside using what? Using chain rule. When you differentiate 2x, you get what? So you divide by 2. Now here, you can be able not to add the constant of integration. So my final answer should be given by negative x all over 2 cos 2x plus now what? A quarter sine 2x plus c. So the constant of integration, I will really encourage you to add it at the end. I will really encourage you to add it at the end, the concept of integration. At the end, at the end, at the end. Not when you're integrating the DV, no, at the end. And basically go back to the notes that I had given you on integration by substitution. When you have a function like sin 2x, the same, you just go to the table, you do what? You look at the table and integrate sin what you get. But you remember to come inside and you do what? You divide by the constant that you will be able to get. You can be able to go number 3 now. I choose a different function. I choose a different function. Check this one out. We try this combination, number 3. We integrate x squared and ln what? ln x dx. So what I need you from the class is to tell me which function shall be u from Liate. So from Liate, you tell me which function shall be u and which function shall be what? Shall be v. That is Liate. So which function do you think shall be, okay, in short, ln x will be what? Ln x, will it be a u or a dv? Only that, you can be able to tell me ln x, is it a u or a dv? If you have been following. Yeah, so we're using the acronym LIATE. People who are coming in right now, the acronym LIATE will be able to give you. So first of all, we have to identify where x squared is falling and where ln x is falling. So basically, we had said that x squared is an algebraic function. This one is an algebraic function. Now ln, this one is a logarithmic function. This one here. This one here. This is ln x. It is a what? It is a basically the ln. Remember in basic maths we had done that ln is a special form of what? Is a special form of log to base e. Log to base e. So if I have not the acronym LIATE, and I've said when I'm starting from up, logarithm will always be given by u. Only that. If I'm starting from down, the first function that I meet is x squared. So my x squared will be by dv. Only that. My x squared will be by my dv. So the acronym is usually very easy. So I can be able to come and say that my u will be ln x and my dv will be what? X squared dx. We said we must have a function of dx, so at least when you come to the integration, it becomes easy. So one function, you call it u, I'll call it here. Look at my problem. Ln x, I'll call it u. Then I have here whatever that I'm circling. Look, whatever that I'm circling in green, whatever that is remaining is x squared and what? Dx. X squared and dx. Whatever function that is remaining is x squared and dx. Yes, x squared and dx. So this one, whatever function that remains, it becomes basically your dv. And I've said for my dv, it must have a what? A dx, because I'll integrate that function. Now, after calling like that using the acronym LIATE, I'll differentiate this one. And when you differentiate u, or let me just do du dx. Du dx here, what will I get? When you differentiate ln x, you'll get 1 over x. You're now on the differentiation, remember? Now, for me to get v, I must integrate this function. So when I integrate this function, what do I get? Add 1 to the power, and then divide by the new power. So I'll get what? X to power 3 all over 3. So it's not always that we call your x squared. The algebraic function, you call it u. It's not a must. You're using the acronym to be able to come up with that. So what I'll do now, I'll just put everything in the formula. U dv is equals to uv minus v du. So my u My u, we had called it as what? My u was, let me go up. My u was ln x. So I put it in the formula, ln x. Then my v, I've integrated x to power 3, 1 over 3, minus my v again is x to power 3, 1 over 3. And then my du, check my du, make this one the subject of the formula here. Check this one out. The subject of the formula, what will I get? So here it means that du will be given by 1 over x dx. That's how we are getting. So du is given by 1 over x dx. So I'll have here 1 over x dx. So I open up the bracket. So we said the first part we just simplify or leave it the way it is. We can simplify, so I can start with x to power 3, all over 3. Simplified. This one I can be able to simplify. I can be able to cancel the x and the x to power 3. So I remain with what? The integration of x squared all over 3 dx. So I have cancelled. I've cancelled the x, this x here, and that one here. Remain with 2. To remain with only 2. Now, this function is easy to integrate, is an algebraic function, this one. So the final answer will be x to power 3 all over 3 ln x minus this one. When you integrate this one, what do you get? You'll get x 3, sorry, s to power 3. Remember, 1 over 3 is not playing any part. I can be able to remove it outside, all over 3. So you add 1 to the power and divide by the new power plus a constant of integration. And the final answer should be x to power 3 all over 3 ln x minus 1 over 9 x to power 3 plus c. That is the final answer. So if we are good at knowing which function we shall call it u and which function we shall call dv, then you are done. I don't think we'll have any problem. Let me do another one. And then I comment. There's something on the notes on tabular form of integration. So let's say we have x squared cos, let's say cos x dx. When integrating such a function. So for this one again, we shall come back again to the acronym. This is number 4 now, LIATE. So I'll check where my cos x goes to trigonometric. This one is cos 2x, sorry, cos x. Then this one will be the algebraic, that is x squared. So you identify where the functions are falling. So we had said x squared, x to power 3, x to power 5. Those are just algebraic functions. They are just polynomials. Then the t stands for trigonometric. The e stands for exponential. The I stands for inverse, and the L stands for log. So going down, we can just have one. Instead of having two, we can just use the down one, like that. So this one will always be a u. That one will always be a u. So which function, if I go from up going down, which function will you approach first with u? Basically, it will be x squared. If you go like that down, you can be able to see the first function according to the table of LIATE, or the acronym LIATE. The first function that we are seeing that will, first of all, starting from up going down, the first function that we shall come to is just x squared. So I'll call that function what? X squared. And then now my dv is whatever that is remaining. That is cos 2x. Or I mean 2x, just cos x dx. Cos x dx. Cos x dx. If you started from down, check, you could have still have gotten the same thing. Now we said what? We need to differentiate the u and integrate the what? The dv, because we need the v in the formula. So here du dx, here du dx will be given by 2x. So here, if I need my v, I'll have to integrate this function cos x dx. So let's get this one. So I need du. Du will be given by what here? Here du will be given by, if I make du the side of the formula, if I cross multiply dx. Now here v, when you integrate cos x, go back to the table. Go back to the table. Have you checked cos x? When you integrate, you'll get what? Sin x. You'll get sin x. So in an exam or a CAT, because you are doing the exam online, I recommend to you, you just either you have your SNP, you can have SNP with you, or you can just download a table in the internet, print it, and you'll be okay. You'll be okay. So, and we have said when you're integrating the V, please don't add a constant of integration here. We shall add a constant of integration at the ends. So now I'll use the formula u dv is given by uv minus v du. So I go back. What have we called our u? I go up. Our u was, let me go up. Our u was x squared. Yes, our u was x squared. So you're just plugging everything. That is x squared. And then our v is sin x. It is here. Minus the integration of our v is sin x. And then our du is what? 2x dx. So I'm plugging in everything the way it is. From there, I can be able to simplify. So we have said the first part here, the one that I'm writing, I'm circling in red, this one. The one that I'm circling in red, there has already been integrated. How do I know that it has already been integrated? Is it magic or what? There's no integration sign, only that. There's no integration sign. So it has already been integrated. So I'll just open up that one. So this one I'll be able to get as x squared sin x. Now I can be able to remove the 2 outside, is not playing any part. And then it's always good to start with the x. Then I have sin x dx. So the only question that I will pose now, how do we integrate here? How do you integrate this one? Let me, the one that I'll circle in blue. Because now the first part we have said we have already integrated, so we need to integrate this one here. How do we integrate that one? I'm posing a question to you. Ideas? How shall we be able to integrate that one? X sin x dx, that one there. How shall we be able to integrate that? Is a product of what? It is a product of x and sin x. So again, we shall have to employ integration by parts here. Excuse. So we shall be able to integrate again x sin x using integration by parts. After we have integrated, then we shall come back and replace it now in this formula now. So that is another task now. So this one, the only way you can be able to integrate is by parts. So again, I'll call one function u, the other function I'll call it dv. If I go back to Liate, this one, so I want to integrate this function x sin x now. The answer that I'll get, I'll come and replace it back. So what we are saying now, I'll still have to use Liate again for this one. I'll have to use Liate again. Liate. So x is here on the algebraic, and then trigonometric we have sin x. If I'm going down, this one is my u. So it means that what? That our u will be x, which means that du all over dx will be given by 1. That is for sure. Which means that du will be given by dx. Now whatever that is remaining there, I'll give it as my dv. So my dv will be whatever that is remaining, sin x dx. I know it's a bit cumbersome, but you have to be able to do this. You get the answer and then you replace back in the formula there. So if I want my v, I'll integrate this one, integrate sine x dx. Go back to the table. When you integrate sine x, you get negative cos x. Please don't add a constant of integration there. I had said we shall add equal later. So this one, what shall we get now? I'll plug in the formula uv, u dv is equals to uv minus v du. My u was x, my v is negative cos x, minus my v is negative cos x, and then my what? My du is dx. Is dx. That one is dx. Is dx. I open up the bracket again. Let me see what I'll get when I open up the bracket. I'll get negative x cos x. A negative times a negative plus cos x dx. Now you can be able to see we don't have any product now. There's no need of using what? There's no need of using integration by parts. We only use integration by parts when you have a product of two functions. So what we have here is just a trigonometric function that we can easily integrate. So when you integrate cos x, when you go back to the table, what do you get? Cos x. You get what? Sine, yes, sine x. Now you can add now a constant of integration now. So when you integrate cos x, you'll get sine x. Again, you can be able to see the first part of negative x cos x have not integrated. Already, it is we had already evaluated. So I go back to the equation that I had now here. I go back because now I've been able to integrate the function that I wanted. I go and then I replace it. What did we have before we integrated that one? You must always be able to go back now. So check this one out. What we had is what we had. Is what we had before integrated. So it means that our answer was x squared sin x minus 2x sin x dx. So again, I'll repeat what I have. And then, no. So this one here, so this one is the integration of, it is here, this one here, whatever we have done here. This one is the integration of, this one is the integration of x sin x dx. Now that we have done this one there. So let me go back to the function that I had. The function that I had, it was telling me that when you integrate x squared cos, I think it was cos x. First of all, what we are getting is x squared sin x minus 2x sin x dx. That's the first integration by parts we did. But we have come later on and integrated this function here. Function that is here. This one here. It is up here. So I just need to replace it now. So I'll be able to get now x squared sin x minus, instead of having x sin x, because I've integrated by parts, I'll have minus 2, the function that is up there, minus x cos x, and then plus sin x, and then plus c. When I open up the bracket, let me see what I'll be able to get now. So I'll be able to get x squared sin x. A negative times a negative, I'll be able to get negative 2, sorry, positive 2, x cos x. A negative times 2 times positive, I'll get negative 2 sin x, and then finally negative 2c. Negative 2c. Negative 2c. That is what I'll be able to get. And in some books, if you check clearly, this negative 2c, you can be able to call it another constant if you prefer. This one, you can call it one. You can call it, let's say, constant d. If you don't want a negative 2c, look at the example that I have done. You can be able to call it another constant d, and then just have plus D or plus K or plus H, whatever the letter that you prefer. So that one has more, but the most important thing is the integration by parts. You can be able to integrate even levels. You integrate the first part, then you end up still with a product. Again, you integrate a second part. Even you can integrate even a third part. When you're integrating like this function here, I want you to go and try later. This function here. This one you'll have to integrate by parts. This one x to power 3. Let's say cos x. This one dx. This one you'll have to integrate how many levels by parts? In the previous example, we have done 2 levels. So this one you'll have to do three levels of by parts. This one because of the x to power 3. Because first of all, you'll differentiate x to power 3, you'll get 3x squared. Then when you differentiate another time, you'll get 6x, and then you differentiate until you get a con. So this one will have 3 levels. 3 levels of integration by parts. Integration by parts. 3 levels. So I think the notes that I've given you, for me, to just to give you an overview. If you go through the notes, I think it will be much easier for you to be able to understand. 2 things: the formula, the integration of UdV will be given by UV minus VD. That formula you must remember. The second thing, LIATE, the acronym. The acronym will assist you to know which function that we shall call your U and which function we shall call your dV. Anyone with a question so far? Because I want now to go to still example if it will be able to work the tabular. Because you have said for the tabular, for it to work, we have said only works when U is algebraic. So let's see. If here, so we have LIATE now. Let's go to LIATE. So LIATE. So we have here x is always algebraic. Ln x we said is a form of what? Logarithm. So ln x will be there. If I go down like this one is my u. The first function that I'm approaching is what? Is u. So yes, correct. U will be ln x. And here what? My dv will be now the remaining function, which is x dx. X dx. So this one, the tabular cannot be able to work. Why? Because you can be able to see that your u is not algebraic. Algebraic is the x. We have said the x squared, x to power 3. So this one tabular method will not work. So here I can be able to say tabular will not work for that one. So you don't use tabular for that one. So tabular will not work. Why? Because my u is not algebraic. It is ln, logarithmic. So it will not be able to work. So the tabular only works when you have u to be algebraic. Let's do the example that we had done, and you tell me which one is faster. So we had this is what we had. We had x squared cos x dx. That's the function that we had. So what I want to do is first of all do LIATE. So LIATE. So we have here x squared as algebraic, and then we have cos x here. Cos x as what? Trigonometric. So if I go down here like that one, like q, you can be able to see the algebraic will become what? Will become your u, and that's okay. So here your u is what? We have said your u is what? Your u is x squared, that's correct. And your dv, the remaining function is what? Cos x. And that's okay. So this one tabular can be able to work now. Tabular can be able to work now. You want to compare the answer that I got and using the tabular, because they should be able to give us the same answer. What I'll do, just like the name, I'll draw a table. I'll draw a table. Draw a table. Like that. Having two. So this one is my function what? This is my function u, which we have called it is x squared. This one is my function dv, which we are calling what? Cos x. So our u, we said what? Our u, we always do what? We always differentiate. So I'll differentiate the u until I get a 0. Just differentiate. We just differentiate the u until we get a 0. So when I differentiate x squared, someone to try. When I differentiate x squared, what do you think I'll get? When I differentiate x squared, so the u we always differentiate, the dv we always integrate. Why? Because I want a v. So I'm asking, when you differentiate x squared, what do you think you'll get? Oh, sawa. Duncan, thank you. You'll get to x. That's okay. Again, I'll differentiate another time. So you continue differentiating until you get 0. So when you differentiate 2x, you'll get 2. When you differentiate 2, you'll get what? 0. So I'm done there. So differentiate x squared, you get 2x. 2x, you get 2. And then what? 0 like that. Yeah. Let's go back to the integration. When you integrate cos x, someone to try from the table. If you have a table, when you integrate cos x, which function do you differentiate to get cos x? That's what I'm asking. When you integrate cos x from the table, maybe you don't have a table, you'll get sin x. When you differentiate, when you integrate sin x, you'll get negative cos x. And finally, when you integrate negative cos x, you should be able to get negative sin x. That is from the table. Remember, the negative will remain because when you integrate cos x, you'll get sin x, but there's a negative, so that's why the negative is remaining. Now, remember this one, we had done it until we reach 0. That's why I had said for algebraic, use algebraic because when you differentiate, you'll always end up with a 0. Now, this is what we do now. We combine these ones. So the integration, you do it until you reach a 0. When you reach a 0, the 0 for the u, you are okay. You just end there. Now, this is what I'll do now. Now, you combine like this now. You combine diagonally. So I'll combine this function with that one there. I'll combine this function with that one there. And then I combine this function like that. So we combine the function with the one that is on the lower side of the dv. So the x squared with the lower. So the arrows have to be diagonal. They have to always be diagonal. The arrows have to always be diagonal like that. The first one with the second one of dv. The second one with the third one. And then the 0 you don't combine with anything because there's no function on the dv that is here. So here where I'm circling here, there's no function. So there's no need of doing what? Of combining there. So after doing that, we assign signs. I'll be able to assign a sign. So the first one here, check this one out. This one, I always assign the positive sign, this one, the first one, then negative sign, and then positive sign. So there's a sign. So always the first arrow will be positive, the second arrow will be negative, like that. They alternate, Positive, negative, positive, negative, positive. But the first one has to be positive. Now the final thing is now just to multiply those. I'll just be able just to multiply now the final answer. So we are integrating what? We are integrating x squared plus x dx. So I'll multiply. So I'll multiply x squared times the positive sign times sin x. I remain with what? X squared sin x. Sin x. X squared sin x. I'll multiply 2x times a negative cos x. So remember the reason of putting the sign was in order for multiplication, I can be able to multiply. So 2x times a negative, you'll get negative 2x. Negative 2x times negative cos x, I'll get positive 2x cos x. Negative 2x cos x. Finally, I have 2. You multiply by a positive and then multiply by a negative sin x. I'll end up with negative 2 sin x. And then I can be able to add a constant of integration at the end. So basically, when you're multiplying, remember you multiply with the sign. If you forget the sign, then your answer will have a problem of sign. You'll have a problem of sign. So you multiply x squared times positive times sin x. You multiply 2x times negative cos x. You multiply 2 times positive times negative sin x. And this is the final answer that we are getting. x squared sin x plus 2x cos x minus 2 sin x. Let's compare with what we had done with you before. We need to compare. If the answer is the same, I hope you have a photographic memory, you can be able to recall all this. So we have x squared sin x plus 2x cos x. Let's go up and see what we got. So we just have to make sure that the first two are okay. So x squared sin x and 2x cos x. So let's go up, see what we are getting. Check the answer. This is the answer that I got in the previous one. Exactly the same. X squared sin x plus 2x cos x minus 2 sin x. We are saying the concept of integration, you can be able to call it anything. So it is exactly the same. So the tabular method is a faster way of integrating. As long as your u is what? Your u is algebraic. You just have to multiply those two. You just multiply with the signs and then you are done. Just multiply with the signs and then you are done. I'll have to do another example. Let me do another example. The notes again will clarify this one for you. This one here. We'll do another one. This integration here. Integration of x to power 3 exponential 2x dx. So this one again, if I use Liate, you're able to see this one is x to power 3, and then this one is exponential x will come here. So if I start from up, u, I'm able to see my u is what? My u is x to power 3. The first function that I get, so u is equals to x to power 3, and then my dv will be given by exponential 2x dx, whatever that is remaining. So this one is a very good candidate of tabular method of what? Integration. Because already I know when I differentiate that function x to power 3, I should be able to get a 0. So I'll do the tables here again. I'll do the table, is faster, the faster way. So this one I'm calling x to power 3. This one is my u, remember? This one is the side of u. Then the dv here. I'll call it what? Exponential 2x, exponential 2x. So let me start differentiating this side of x to power 3. You always differentiate the u. This one I'll get it what? 3 x squared, successive differentiation, then 6x, and I'll get a 6, and I'll get a 0. Now let's integrate this other part. Please don't confuse this other side. We are doing what? We are integrating. So when you integrate exponential x, you still get what? Exponential 2x. But using chain rule, you come inside and you differentiate 2x, you get 2. So you divide here by 2. You divide by 2. Please don't forget that. Go back to the integration by substitution. This is what we are doing. The 2 was coming always down, So now whatever that I have now here, this one again, I'll integrate this function again. Exponential 2x over 2, when you integrate, we'll get exponential 2x all over 2. But again, using chain rule, we must multiply with a factor of 2. So I'll get exponential 2x all over what? 4. Because now the 2 and the 2 will multiply to get 4. I hope you're getting now the rhythm now. So the second one, I should be able to get exponential 2x all over 8, and then exponential 2x all over what? 16. So you continue integrating, and as you continue integrating, you are dividing by 2. You are dividing by 2, you are dividing by 2. So there will be a factor of 2, and then 2 times 2, 4, 4 times 2, 8, 8 times 2, 16, and then you are done. Now from there, what I need to do now is to combine the signs. Let me combine the sign and put the sign. So we said this one diagonally, the first one is always positive. This one, negative. This one, positive. And finally, this one, negative. So the signs alternate: positive, negative, positive, negative. And then you just multiply. So the final answer should be able to get, the first one I'm multiplying, x to the power 3. So the final answer will be x to the power 3. And then exponential 2x all over 2, that's the first one. And the sign was positive, so it will still remain positive. Now let's go to the second one now. The second one, I have 3x squared, and then I multiply with this one. But the sign is negative, so I'll have a negative there. I'll have a negative. So there's a negative here. So minus 3x squared exponential 2x all over 4. The other one, the sign is positive. So positive, the sign is positive. So I'll have 6x exponential 2x all over what? 8. And the other one, the sign is negative. So I'll have 6 exponential 2x all over what? 16 now. All over 16. All over 4. This one was all over 4. You just multiply. This is all over 16 plus a constant of integration. Now this one, it is your task now to simplify. So this one I can be able to write it as a half x to the power 3 exponential 2x minus 3 over 4 x squared exponential 2x. 6 over 8 I can be able to simplify as what? 3 over 4 x exponential 2x. Negative 6 over 16 divided by 2, you'll get 3 over 8 exponential 2x, and finally plus a constant of integration. So the other bit is just about simplification, but it is very, very fast. What we just need to remember is you just have to be good at differentiation, and you're good at integration, and then you have the signs. You have the signs positive, you always start with positive, negative, positive, negative. Signs are very important, because without the signs, the answer that you'll get, you'll not be able to write. So this is what we had before. So the integration, please remember by substitution. When you integrate, you divide by that one, you divide by that one, you divide, and then you have the sign. And then you have the sign. So before even I continue, I think you can be able to go to a discussion whereby you can be doing some, and then you do some, like 2 examples, and then you'll be able to tell me if you are okay with that. So anyone with a question so far?